All right, everyone. Sorry that I was not there in the classroom today, but here's the promised around 7-minute video talking to you about crime geostatistics. So remember, in class the other day, towards kind of while some network processing was going on, I kind of introduced the activity that's due Friday this week at 5, the Crime Geostatistics Lab. And so by following the directions that you'd find on Blackboard, you actually can map out crime in a neighborhood here in Terre Haute, the Farrington's Grove neighborhood, for the year 2008. And I kind of, in class, gave an example, talked through the example about vehicle thefts and how in some parts of the neighborhood there are 3 vehicle thefts. There's only one point, I think, where there are 3 vehicle thefts. That's actually shown down here. And then there are many other points with 2 vehicle thefts. In fact, we can actually look at this. Usually it'll say and count here how many there are. I have to rebuild statistics to do that, but let me make these points a little bit bigger. So you can see here we have maybe one point where 3 vehicles were stolen here over the course of 2008. We've got a couple more points, maybe half a dozen, 8, where 2 vehicles were reported stolen over the course of the year, and then other places where there were 1. And the question that you'll kind of answer working through the lab is, are these points clustered? And visually, I think most people would agree, and you're going to produce a map like this and upload it, so it's kind of a hint. But visually, most people would agree that there's some clustering going on here. But just because you see clustering doesn't mean there actually is clustering. The human brain's really good at what we call Gestalt grouping, or just psychologically, your tendency is to group features together when they may or may not be similar or grouped or groupable. A good example of this is how we can see faces or shapes in clouds when we look at them. You might have done that before. We tend to be really good at, say, recognizing faces, even ones that we've only seen once before, and that's also the same thing. We tend to see patterns where patterns might not exist. So how can we do this? We can actually do this statistically, and for this you're going to be doing a test called high-low clustering, and work through the interpretation there. And I talked about that in class the other day, kind of gave you some pointers on that, and also the assignment does. But as promised, I wanted to show you another tool, because the tool of high-low clustering actually only allows you to basically map out what clusters are, statistically speaking, actually clusters of, say, similar values. Instead, wouldn't it be useful if we could make kind of a continuous surface that would give us an idea of whether crime is, say, more significant in the northern part of this neighborhood than the southern part of this neighborhood? So this isn't part of the assignment, but it's something I wanted to show you as a capability. You might have heard of interpolation. In fact, in your Mastering ArcGIS activities, there is some information about interpolation. Well, kriging is an interpolation method that takes points and makes a raster surface from them. So making sure that your spatial analyst extension is enabled, which mine is, you want to search for the word kriging, K-R-I-G-I-N-G, in ArcGIS. There's a tool here, kriging spatial analyst. I'm not using a 3D analyst tool. It's actually identical, but I don't have 3D analyst. Actually, I think I do. If you have spatial analyst enabled, kriging spatial analyst would be the one you want to use. Now, kriging has many options, as you probably are used to seeing, but the basic ones are, hey, let's input our point features, in this case, crime points. They might be called something different in your case, depending on what you named it when you imported it. And what kriging does is it takes input values at a given location, at this point location. The value has to be a numeric value, and that could be anything. In this case, let's go with all crime. All crime 08 would be the report, or the variable that we're interested in. And so this would be all crime reports for all points in the neighborhood. I'm going to just leave this as the default, but you might want to save it to a location. It's just the output location. And then for most purposes, you would want to use ordinary kriging. Now, what does this mean? Well, essentially a semi-variogram is something is a basically the relationship between distance and the variance that you would observe in a data set. Well, what's variance? Well, it's basically the variation, that sort of the average variation you'd find over the entire data set. So you have a large data set with high variance. That means there's a lot of variability in your observations. If you have a large data set with very low variance, it means there's not as much variability in your data set. Now, if we look up kriging in help, how kriging works is probably a good starting point. And so what you're really creating here, rather than an interpolation, it's actually a surface that predicts the value that you would see there based on distance and the variation in your data set. So distance would be distance between 2 points, and variation would be kind of the variation of values, right? Well, to do this, it actually employs something called a semi-variogram, which is a fancy way of saying a point plot where the x-axis is distance and the y-axis is something called semi-variance. Semi-variance, you can think of this as the kind of variation in the data set, just as a quick kind of first brush way of thinking about it. And so we have some semi-variogram models, which I'll talk about in a second. But we also have our two kriging methods. That's what this ordinary and universal is. Well, ordinary kriging's pretty much normal. This assumes that you don't know what the mean of your data set is, and unless you have a reason to know the data set's mean, the actual mean that really exists, it's not worth doing. I'm sorry, this is the kriging method you select. Universal kriging would ask for a trend that's in the data set. So the example here is a prevailing wind. Another one would be, say, the rate at which temperature changes with elevation, right? And it's basically a way to adjust. If you know there's a tendency in the data set, it removes that tendency. And so that's just to make it so that the kind of assumption of randomness holds, because this is a statistical technique. It needs some component of stochasticity or a random behavior. Okay, so we would go with ordinary in most cases, and then we have to pick a semi-variogram model. This is essentially the distance, again, between your variation in data values, okay, and distance between your points. So if this is all crime, the number of crimes committed at a location, and this is the distance between points, as the distance got greater, the difference in crime, this isn't actually the number of crimes, it would be the difference in the number of crimes between two observations, say, or delta difference in crime, or I'm sorry, delta crime reports, so the difference between two locations and the crimes that they report. Very close together, the distance is not going to be very big, but as you get further and further away, that difference gets larger and larger until you reach some bench point where it levels out. So spherical, that's just going to make that increase. Sorry, there's banging. I don't know what that is. Increase is going, or the increase in the difference is going to be more rapid than circular, exponential. These three are very similar, except for kind of the speed at which they level out. And then there's Gaussian, which is your typical logistic point where close distances, you're not going to see much of delta, and then it increases until a certain point. And then there's linear. I will say straight out that linear relationships in kriging are generally not a good idea, because that would basically mean the difference becomes infinitely great as space increases. It just keeps going on and on. So this is probably not going to obtain in most real cases. Okay, so those are the semi-variogram models. In most cases, you're probably going to want to pick spherical, circular, or exponential, perhaps Gaussian. Maybe in this case, we think that crimes are probably most related to one another, right next to one another. So we'd want one where the number of crimes stays pretty constant until you get further away, and then it kind of increases rapidly till maybe it doesn't increase so rapidly until you get to, say, a different part of the neighborhood and then flattens out. We're going to pick a Gaussian just for illustration purposes. Then you have a couple other questions. Output cell size. In this case, you want to pick something reasonable. This is going to be in spatial units, linear measurement units. you have to set a search radius. It says optional, but my experience is that your kriging, your interpolation is not, or your prediction is not going to be accurate unless you set one of the two options. One is variable. This would be that it will look around each point for the nearest, say, 12 neighbors or 3 neighbors or whatever, and you can set a maximum distance beyond that won't go, beyond it, that distance it won't look anymore, or you can say fixed. I want to look at the closest, or I want to look at a minimum number of points within so many linear units, distance units. In this case, I might say that I want it to have a variable search radius where the closest 4 points are going to be looked at, and I'm not going to set a maximum distance. And then our last thing would be our output variance of prediction raster. So if kriging is actually making a predictive surface, is trying to predict what the values of crime would be between 2 points, right? This variance prediction raster is going to give you kind of an indication of how bad that prediction is. So a high variance would be a bad prediction, a low variance would be one that we'd be a little bit more confident in. So you can output this if you want. I'm going to leave it blank just in the interest of time. So you go ahead and click OK, and it will chug along for a second. Depending on your parameters, it could take quite a while, but it's not the most computationally intensive process. It's just one of them. After a few moments, it'll be done. It might take it a few moments to draw that file. In this case, let's see. In this case, I ended up with a krig that is located not where I thought it was. Hold on. Let's see where this is. Let me see. I've got a spatial reference problem here, of course. I'm going to make this a permanent data. I'm going to change its spatial reference, make it a permanent layer that I can check out kind of more accurately what's wrong here. All right. Hold on. And the product of kriging will be something like this. So in this case, maybe I'll change the color scheme a little. And the product of kriging will be something like this. So in this case, maybe I'll change the color scheme a little bit to maybe a stretched color scheme where actually the classified one worked pretty well. Where we go through kind of a light orange to orange color range. So places here where we have a kind of a lighter color or low crime zones, and then deeper tones of red are ones where we have higher crime reports. Now you'll notice a couple things. If I drop this kriging result, say beneath the neighborhood boundary, you might ask yourself, well, why is it shifted northwest? Well, kriging, the extent of a krig, or any interpolation for that matter, is going to be determined by the extent of the input data. And in this case, our last point is, say, in this row, and then we have one up here. It's going to fill in data, kind of at the margins or as far away as it can given the data points. The reason why it goes all the way to this line is we have a point here. So it will fill in a block, but we don't have any points below this, meaning that we don't have any data to fill in here. A couple other items. This is an approximate interpolation, meaning that it doesn't honor the original data. So if our number of crimes was, let's say, 12, you'll never get a map where there's a zone with 12 crimes in that area. It will always be lower than that. By the same token, you might have places that had no crime. You'll never get, let's say, a 0 crime. It'll always be slightly higher because it's kind of taking all the information in the data set and coming up with a distribution based on that. It's always going to be limiting at the extremes, so you're never going to honor the input data. But this is a good way to make surfaces, predictive surfaces, out of lots of different data types. Anything that's a point, you can turn into a surface and make kind of a alarming, if you want, an alarming map. If you showed this to your average Terra Haitian, they'd be very freaked out to live up here. Now, does that mean it's worse in other parts of the city? You'd need more data, right? But this is another way that you can make kind of a nifty display of point data. Kriging and other techniques like inverse distance weighting are used extensively in the social sciences and in the natural sciences, especially in natural sciences like climatology, where we're kind of taking points and interpolating, say, temperatures or rainfalls over broad areas. In fact, just in closing, we're probably beyond 7 minutes now. But in closing, if you go to any weather.gov website and look at some of the maps that they have, say the National Digital Forecast Database, these maps of, say, surface temperature, right, or wind gusts are totally based on interpolation techniques similar to Kriging, and they're based on observations and their predictive output, not a deterministic one. So just because it says we're going to get 0.02 inches of rain doesn't mean that we're going to. It just means that we're likely to, which you get with a weather product, but maybe would be harder to rationalize with something like crime that seems deterministic, but is being mapped in a probabilistic fashion here. So anyway, it's basically predicting there will be 4 crimes here. That's my prediction, not there are 4 crimes here, right? So anyway, just another method to map and manage data. Kriging is very powerful, and you can even do something called co-Kriging using some geostatistical tools that are available to you in the ARC toolbox area in the geostatistical tools. Right here, we can use some, let's see here, empirical Bayesian Kriging. Gets very complicated, but is very powerful and adds kind of another layer of quality to your analysis. So anyway, I'll see you on Wednesday, and have a good Tuesday. Oh, don't forget, Friday, there are actually 2 things due. Check out the syllabus. There's the move deadline on the crime geostatistics. This project is 5 p.m., but there's another item that hopefully you can have some fun with that's also due on Friday. So anyway, have a good one. I'll see you Wednesday.